Good evening, everyone, and welcome to everyone joining us from across the globe. I'm Dr. Aishwarya Sharma, and I have the privilege of moderating today's session of Med AI Web Hour. We are here to explore the theme that is transforming the very fabric of healthcare, where artificial intelligence in public health and genomics takes place. AI is no longer a futuristic concept. We are already using it and driving meaningful change in the field of medicine through AI. We are honored here to have with us two distinguished guests, thought leaders, Dr. Kaushik Mitra and Dr. Kamaldeep Chawla, who will be taking us through this journey for over the next hour. So over this next hour, you can expect engaging insights, forward-looking perspectives, and practical implications that will inspire all of us to think differently about the future of healthcare. So without the further ado, let's dive in. To begin, I would like to invite Dr. Kaushik Mitra, sir, to share his talk on transforming public health in AI in India with AI. So, Dr. Kaushik Mitra, sir, is a professor in community medicine at Burdwan Medical College, Secretary General, Indian Public Health Association. He's also a fellow at Indian Public Health Association. His major achievements being he has around 35 articles in national and international index journals. He is author of chapters in 3 textbooks. He's a resource person in, team, could you? Yes. Excuse me for that. He's a resource person in national and international conferences and workshops. He's a vice chairman, state task force of NTEP West Bengal. He's the principal investigator of MINERVA for West Bengal and Sikkim. He's the editorial board member of IJPH and ESRF RJUMS. He's a reviewer of many national and international journals, internal and external examiner of many universities. He's also the quiz master of national level public health quiz competitions. I welcome you, Dr. Kaushik, sir, and I hand over the mic to you for the session.
Thank you, Dr. Aishwarya, and good evening, everyone, wherever you are across the globe. So today we have an interesting topic. Yes. So today we have a very interesting topic, that is use of artificial intelligence, that is AI, in public health. We use AI in different aspects of our life. We use AI in different aspects of our health systems. But what is the real utilization of AI as of now from public health point of view? Being the Secretary General of Indian Public Health Association, I would like to share some of the aspects. It cannot be all because it cannot be completed within an hour. If I describe all the aspects of using AI in public health, I will definitely go through few of the aspects of using AI in public health. So I start with the words of one of the greatest scientists, Stephen Hawking. He once said, "Our future is a race between the growing power of technology and the wisdom with which we use it." So it's a race. Now I come to the most intelligent question, that is, what is artificial intelligence? We define it in many, many ways. Some says it's a technology that enables computers and machines to simulate human learning, human comprehension, problem solving, decision making, creativity, and autonomy. So we can see there are so many aspects. It can simulate human learning, comprehension, problem solving, decision making, even creativity and autonomy. Again, we can say it's a software program that can simulate a context-space sensitive response or a conversation that is in the form of a chat. With a human user, we can chat with AI, so we can have a conversation in natural language. Through messaging service, we message it, we can chat with the software program. Websites or mobile applications nowadays, the freely available AI, there are so many AI which are freely available over the net, like the GPT, currently provides a popular AI chatbot interface named as ChatGPT. It's a brand created by the AI research and development and deployment company that's OpenAI. So there are many more also, not only ChatGPT, there are so many more through which we can chat. It's a software program through which we can chat and have a conversation and get something back from it. So it started in the 1950s, when the first human intelligence was exhibited by the machines as artificial intelligence. In 1980s came the machine learning. That's the AI systems that learn from the historical data. We feed the AI systems with the historical data of many, many years. And after feeding them, they use the artificial intelligence to deliver some new data. In the 2010s came the deep learning. That is the machine learning models that mimic human brain function. And at last in 2020, when COVID sets in, there is also the setting of generative AI. That is the deep learning models that can create original content based on the historical data that we have put. So this is how artificial intelligence, machine learning, deep learning, and generative AI are related. So it generally refers to the performance by computer programs of tasks that are commonly associated with intelligent beings. And it is the ability of the algorithms encoded in the technology to learn from data so that they can perform automated tasks without every step in the process having to be programmed by the humans. So they learn from the data and they bring out the data without every step being formulated by the human. That's why we call it artificial intelligence. They become intelligent enough to give back some data to human being. Now I come into the topic proper, that's the applications of artificial intelligence in the field of public health. First of all, we talk about the disease surveillance and outbreak prediction. From the time of COVID, we are always familiar with these sorts of jargon: surveillance, outbreak, pandemic, epidemic. So now we come, how can AI be used for disease surveillance and outbreak prediction? So first of all, we have some real-time data integration. That is, AI system ingest, that is, we feed them massive data sets from electronic health records, even social media, satellite imagery, climate data, and even wastewater analysis to detect anomalies and early warning signals. That is, we feed the software with massive data sets from different angles, from health records, from social media records, and so that they integrate among themselves and ultimately they can detect some early warning signals from the social media. If they see something that some outbreak is going on somewhere, again some others would write in the social media, different social media, they gather this data and give us the warning signals. So it's from a Nigerian Delhi, the nation, where we can see this person, Mudel, he champions AI-powered early warning systems for disease outbreaks. So as climate change heightens the rise of infectious disease worldwide, this Nigerian-born researcher is gaining recognition for pioneering efforts in developing early warning signals that use satellite imagery, geospatial data, and artificial intelligence to prevent and predict outbreaks. Now I come to the pattern recognition and forecasting. The machine learning algorithms identify subtle patterns in the disease that spread that human might miss. These models that can forecast outbreak days or weeks in advance, allowing the health authorities to mobilize resources early. So if we can forecast early, we can mobilize our resources early. Natural language processing. They scans platforms like the Twitter, that is X handle nowadays, or news feeds from spikes in symptom related posts, or even some small keywords, flagging potential outbreaks before the official reports come out. So before the official reports come out of an outbreak, they scan different news feeds and tell us. Even climate smart surveillance, AI links climate variables like change in temperature, rainfall, vegetation to disease trends. How, how much change in temperature can bring about some change in some infectious disease or vector-borne disease due to some breeding of mosquitoes, difference in temperature, so they can detect malaria and dengue. So even this is also reported in a journal by in Chance School of Public Health, Harvard TH, uh, that is Climate Smart Public Health, which is a blueprint for resilient health system. From outbreak prevention or prediction, I now move on to some epidemiological modeling, the use of AI in different modeling in epidemiology. So previously also there are some modelings in epidemiology. You have seen different models that come out, but using of AI have made them more robust. It simulates the disease spread under different scenarios and help policymakers to evaluate the impact of interventions like lockdown or vaccination drives. Emergency preparedness and response. AI systems simulate disaster scenarios and guide public health responses to pandemics, natural disaster, or bioterrorism. So, different modelings we have seen from the days of COVID. AI models predicted case surges and helped optimize the lockdown strategies. Vector-borne diseases like the dengue and malaria that I was speaking about. Even in HIV/AIDS, AI is being explored to model transmission dynamics in high risk populations and evaluate the impact of awareness campaigns. So, AI and epidemiology can combining these two predict pandemics. This was an article published very recently on 16th July 2025 by the University of Florida. So, artificial intelligence has definitely proved to be a tool in predicting pandemics. But in a scoping review covering many studies, around 15,000 studies, scientists have weighed the pros and cons of using machine learning in epidemiological models. There are some pros, there are some cons. Definitely, it will go on and on and on. So, we have to analyze the risk benefit of it. Now, I come to another aspect, that is health promotion and behavior analysis. AI tools monitor behavioral patterns and tailor health messages to specific populations. Chatbots and virtual assistants, they support mental health and chronic disease management. If someone is suffering from depression, he is advised to use some chatbot. He writes his own feelings. There are some virtual assistants or chatbots that recognize the insight of it and give them some answer as a part of the conversation. Health resource optimization, where we can predict demand forecasting. There are some models that analyze historical data, disease trends, and environmental factors to forecast demand for hospital beds, medications, vaccines, staff, so we can mobilize or optimize the health resource. Just like COVID-19, I helped to predict ICU occupancy or the oxygen needs many days in advance, not in the first stage of COVID. Maybe when the data were fed to the AI softwares after some days or after some months, they bring about help to bring about this prediction. Now come to the smart supply chain management. AI tracks inventory levels, predicts shortages, and automates the procurement. So it's a type of smart supply chain management. We have some workforce allocation. AI tools optimize staff scheduling by analyzing the patient load, skill sets, and fatigue levels. It helps to reduce the burnout and ensures critical areas that are adequately staffed. We all know that AI has a definite place in the imaging and diagnostics. So AI models analyze X-rays, CT scans, MRIs, even pathology slides, but not as the best as human beings can. It's in the process of development, and obviously it depends on the humans. Humans, AI cannot replace the humans. To detect the abnormalities like tumors, fractures, if we feed them some X-rays with fractures, ultimately after such feed, they will definitely tell which X-ray is fracture. These systems often match human accuracy in the fields. They almost match, but still we require human accuracy, like radiology, dermatology, ophthalmology. Early disease detection. AI can spot subtle patterns invisible to human eye, enabling earlier diagnosis of disease like cancer, TB, and cardiovascular conditions. AI tools have shown higher sensitivity and specificity in detecting some early stage lung nodules. They can detect some early lung nodules that may progress to cancer or the earlier stage of cancer. Even diabetic retinopathy in the field of ophthalmology, sometimes it can be predicted by using AI. AI integrates imaging data with the patient history. So it's a multimodal diagnostics. Not only imaging, we have the imaging data, we have the patient history, we have the lab results, we have some genomics. And so, based on all this, it gives a holistic diagnosis. So it's just like human brain, where when we examine patients, we do some investigations, we do some imaging, we have the history of patients. It's the same, almost the same as the human what we do in our real life situation. But it helps in reducing the diagnostic errors. So it's on the Economic Times government role. It has come out in a blog. So role of AI in diagnostics, improving accuracy, enhancing data analytics, and efficiency in disease reporting. So there are some initiatives in public health from using AI. There are some initiatives taken by the government of India to use AI in the field of public health, like AIMS Delhi, PGI Chandigarh, AIMS Rishikesh. They have been designated as centers of excellence for artificial intelligence with an aim to promote development and use of AI-based solutions in health. So we have the media disease surveillance, supporting event-based surveillance for infectious disease put to use. So we get some alerts from screening of different medias by AI. Then we came to the clinical decision support system that has been integrated into eSanjeevani to enhance consultation quality and providing AI-based differential diagnosis. So it has been incorporated with eSanjeevani. So there is another initiative by in the field of tuberculosis, that is cough against TB. It's an AI solution being used for screening of pulmonary TB in the community settings. There is another AI solution that is prediction of adverse TB outcomes. How much adverse TB outcomes may occur. So they can be predicted by using AI. But there are some major barriers of integrating AI and public health. I will discuss a few of them only. Like many public health professionals lack formal training in AI, or they feel overwhelmed by its jargon or complexity. Even some with technical background, they may struggle to apply AI meaningfully in the field of public health. So we can come out with a solution of hands-on training programs tailored for our public health teams. Even inadequate infrastructure, many regions, especially in the developing countries, they have the tech backbone needed for AI. We lack it. So there is scope of investing in this cloud-based platform and mobile-compatible tools. Shortage of technical expertise. definitely we can have some more technical expertise from interdisciplinary teams, and we can pair public health experts with the data scientists so that the technical expertise there won't be any shortage. There are some concerns regarding the privacy, bias, and misuse of AI tools. So there are some ethical and regulatory challenges as well. So we have to adopt a systems thinking approach to regulation. How do we regulate? How much do we use AI? And where we don't, where we will not use AI? That is some of ethical issues. There must be some regulation. There are some regulatory challenges. So we can engage communities in ethical discussions for trust building awareness campaigns. So there are some disease surveillance and early outbreak detection also in some low resource settings can be done using AI. They can do some predictive analytics, that is a smarter surveillance with limited resources. We don't have much resources. AI models can forecast some outbreaks by analyzing the previous health data. We can have some mobile-based monitoring services in places in rural India where there are AI-powered mobile apps which are given to some frontline health workers to input symptoms, history, local conditions, and can detect some early signs of outbreak. Now, even the social media, there are some AI which scans the social media through natural language processing tools, local news, for unusual health-related data, offering early warning signals before the official reports come in. So this is a article from the Lancet Public Health, where artificial intelligence in public health promises, challenges, and agenda for policymakers in public health institutions. We can go through this article. And there's another document by the World Health Organization, WHO, where ethics and governance of artificial intelligence for health, it's given as a guideline. You may also go through this guideline for further reference. Thank you all.
Thank you so much, sir. Thank you for such a detailed talk. You extensively covered so many topics, as well as you intensively went in each topic as well to tell about how AI is transforming the whole public health domain. Thank you so much. That we have a few audience questions, and if you would like to take them. The first one is, how do you see AI improving the disease surveillance in early outbreak detection in low resource or rural settings?
Actually, I've discussed it in the last few slides that even in the low resource settings, maybe rural settings or some or urban low resource settings, there are we can do some data mining by with the help of some social media or news items. AI can get the feed from there and can predict some outbreaks. So that's one of the most important aspects which we can use in the low resource settings. AI
And
can get their feed from the news items, from social media, from other health related data, and can bring about some early warning signals as well.
Right. And the other question is, what are the biggest barriers to integrating AI tools to large scale public health programs, and how can they be addressed?
That also, I have already said that there are some barriers as well. Uh, I can share once more if you allow. See. So there are some barriers as well, which I was talking about. Just a minute. So these are some major barriers of like lack of familiarity, lack of confidence. We can have some training programs for overcoming this barrier because it's a new concept. And so the professionals, most of the public health professionals, they lack the formal training. Even there are inadequate infrastructure, it will take some time to build the infrastructure. We have to invest in some scalable cloud-based platforms and mobile compatible tools. We have the shortage of technical expertise. So there can be a association or combination from interdisciplinary teams where we can pair the public health experts with the data scientists. And at last, there are some ethical and regulatory challenges that we have to make some regulations, some act, where to use AI, where not to use AI. So it's it's a win-win situation.
Also, sir,
So also,
during the talk, I thought that how, like, what frameworks are emerging? Like,
I
how do
can't
we?
hear you.
Hello. Can
Hello.
yes? Can you hear me?
Yes, yes.
Yes, sir. So I was wondering, what are the frameworks that are emerging, which will help us to validate, like all the real-time signals? Like, how do we validate them?
Actually, it's difficult to validate. It's a newer concept. So right now there are some signals that we can see that what AI is giving some signals, such as a signal for an outbreak. So we can wait, actually government or the community, we can see whether it's validated or not, whether the outbreak really takes place or not, or whether there is a chance of having outbreak and we can prevent it or not. So it's not the time that we depend on AI entirely. It's not the time has come for it. Definitely one day, we don't know, the AI will be more than human or not.
Got it. Thank you. Thank you so much, sir. Thank you for your
Thank
talk and
you.
for taking up all the questions. We move ahead to our second speaker, Dr. Kamaldeep Chawla, sir. Before that, I would like the team to share the screen with Sir's CV so that I can introduce. Okay. Thank you so much, sir, for agreeing to give a talk on such a niche topic of genomics in AI. And I would like to introduce our audience to you. You are Dr. Kamaldeep Chawla, sir, MD DNB card FRCP. Wow, list of degrees, FICC, FESC, FACC. He's a fellow in interventional cardiology, ICPS France. He's a director, medical affairs and HOD of cardiology at Ward Wizard Hospital, founder member of Indian Diabetes and Cardiometabolic Disease Association. Awarded the Best Cardiologist Award in Western India by IPSA at New Delhi 2016. NBSL 2017 award, Cardiologist of the Year in Ahmedabad zone by APS Media and Research, New Delhi. Best Consultant Cardiologist of Western India Award in 2018 by Eminent Research, Mumbai. Times Icons of Vadodara Award in 2020 as well as 2022, and Times Gen Next Award in 2024. I welcome you, sir. It's an honor to be having you as a speaker. And I would like to give the mic to you to start your presentation.
Thanks, Dr. Aishwarya, for those kind words. I am not able to share my screen till you allow me.
Yeah.
And I would also like to thank Dr. Day at the outset because we met for a brief during one of the conferences. Then he wanted me to talk on this topic. So about AI and genomics. So he told Kamaldeep, I want you to talk on the topic as a clinician, but talking about AI, the hardcore technology. So that is what the need from Dr. Day was. And so let me take you through this journey of Gene Sutra, of which I am the founder. And it's an AI enabled personalized genomics, your genome, your future, your health. So are my slides visible?
Yes, sir. Yes, sir, they are visible.
Yeah, but yeah. So, friends, the problem is lifestyle and chronic diseases. Yeah, definitely the number one global health challenge. And if you consider cancers as lifestyle disorders, then it becomes a massive challenge. Healthcare is reactive, not preventive, as we traditionally practice it. The other problem is that genomic data is often locked away by providers, and users and doctors lack personalized and actionable insights. I have taken lecture on genetic testing to predict cardiometabolic disease almost around 50 cities in India. And I can assure you that healthcare providers are also not aware of how to order the tests or what test will do what. But everybody is aware that yes, genetic basis to the disease is definitely a problem and we need to tackle it. So friends, introduction to AI in genomics in particular, our previous speaker has in detail told us about artificial intelligence and then taken us through his journey for public health measures. So AI is definitely helping in revolutionizing genetic research. The computer systems that can perform tasks requiring human intelligence. Genomics is the study of an organism's complete set of DNA, and it's in billions and trillions of data in terms of binary code. And with the advent of artificial intelligence, it has become very easy to analyze and understand this data. AI technologies are transforming how we analyze, interpret, and apply this genomic data. And the impact is it's accelerating into disease understanding, drug development, and personalized medicine. So AI is creating a world that has never been seen before. By applying AI to genomics, we have the chance to revolutionize healthcare and improve human lives. The fundamentals of AI in genomic analysis are machine learning, so algorithms that improve through experience, identifying patterns in genomic data. So what it basically means is when United States, under the leadership of US and then all other countries and regions got into the program, the genome-wide application study or the Human Genome Project. So we have volunteers whose genes are fed into the system, and in machine learning algorithms go on to improve the experience, the depth of the genes and the variety of genes that are captured by artificial intelligence goes on to grow tremendously. Deep learning are neural networks with multiple layers that can extract complex features from raw genomic sequences. By natural language processing, it's analyzing genome sequence as a biological language. And computer vision is analyzing microscopy images and structural genomic data. So basically, the AI in genomic typically follows a workflow of data collection, pre-processing, feature extraction, training, validation, and deployment. So as you can see in the cartoon that is on the right panel, so after having gathered a genomic data, mostly blood that is used, now even saliva samples are used, but in saliva the accuracy is low and the depth of genomic data is less. And then with our AI co-pilots and our technologies and our patented algorithms, training prediction models go on to give us an exact report of a human gene. The application of AI in genomics is multiple. Gene sequencing analysis, that is improving accuracy and speed of DNA sequencing while reducing costs. Variant identification, that is detecting genetic variations associated with diseases and traits. Disease prediction, that is predicting diseases risk based on genetic profiles. And drug discovery, that is accelerating in development of new treatments through genomic insights. What each of these means for a clinician is that having pools and pools of data, when you get a crisp one-page summary of the report of your patient, then you can understand, okay, these genes are a problem and this is the disease which can happen. When we identify variant identification and disease traits, we basically want to identify the genes which run in families and what they are doing to the generation and the next generation. By having massive data in terms of polygenic risk scores that are made through AI algorithms, we can actually predict the disease, that whether this patient will go on to have diabetes later on, or hypertension, obesity, cancers, coronary artery disease, sudden cardiac death, cholesterol problems. So these are majority of diseases which we can actually predict in advance based on the applications of AI in genomics. Not only drug discoveries and newer treatments, because now is the era of gene recombinant treatments and proteomics and many of those fields which are coming in. So how a drug will affect a particular gene can also be studied by AI. So AI is basically transforming genomics across the entire research and clinical pipeline, from basic science to patient care. What is the role of AI in DNA sequencing? So increase speed, because definitely what humans would do calculating each information, AI can definitely do it at a much faster speed. enhanced accuracy by reducing errors in base calling and sequence assembly, cost reduction because you are saving time, and novel insights by identifying patterns in genomic data that humans might miss. So AI is helping achieve the goal of $100 complete genome sequence, making personalized medicine increasingly accessible. AI-driven precision medicine, the right treatment for the right patient at the right time, that is the promise of AI-powered precision medicine. So by genetic profiling, AI analyzes individual genetic variations. Then by risk assessment, we can do predicting the disease susceptibility based on these genetic markers. And based on that, we can do treatment selection, identifying optimal therapies based on genetic profile. So, for example, in very recent times, we all have been using statins to treat our lipid profile abnormality patients or high LDL patients. Now, based on the genetic report, or if you find genetic variations, you can stop statins and go on to prescribe PCSK9 inhibitors, that is inclisiran and those group of molecules which are recombinant proteins or gene-based therapies. And outcome prediction in forecasting treatment response using AI models. What is explainable AI in genomics, that we call it in short form as XAI? It is essential for clinical adoption of AI in genomic medicine, providing the why behind the predictions. So, for example, the cartoon shows that you analyze a car, its wheels, its assembly, and then you get each image and pixel, and then you go on to get a map of the car. Similarly, for each region of your, say, X chromosome or Y chromosome, you analyze exons, introns, and you see their location and direction. And you can find many single nucleotide polymorphisms. You can find out many genetic deletions, and all those can be identified with the help of AI. Not only that, AI brings transparency, it brings causality, it brings bias detection, and it brings trust building into the profile of genomics. So the benefits of AI in genomics is that it can definitely provide good data analysis, more into the depth of the genetic material, enhance accuracy, increasing efficiency, and enable precision medicine in genomics. And more than that, it brings in early time frame of giving the report and also cost efficiency by that. Definitely, there are challenges and limitations. So data quality and quantity, we need large, diverse, well annotated genomic data sets. So for example, the brand that we use, GeneSutra, we have 8,000 Southeast Asian volunteers. We have 5 lakh European patients data and 3 lakh American patients data. As we get more volunteers or more patient data, the AI algorithms by machine learning, the predictive accuracy goes on to increase and the bias goes on to decrease. Definitely, there's privacy concerns. There are regulatory issues and bias in representation, ensuring models work across diverse populations. The future directions or the emerging trends in AI genomics is federated learning, that is collaborated AI training across institutions while preserving data privacy. Multimodal integration, that is combining genomic data with other biological and clinical data. Democratization, that is making AI genomic tools accessible to researchers worldwide. And real-time analysis, that is point-of-care genomic testing with immediate AI interpretation. At present, the majority of gene data that we get, or the reports that we get, have a turnaround time of 3 to 4 weeks. So the convergence of AI in genomics promises to transform healthcare, agriculture, environmental science, and our own understanding of life itself. So particular about GeneSutra, that is our brand, what we are doing using AI. Definitely our vision is empower every individual with the genomic blueprint enhanced by AI for lifelong treatment. It is under my leadership. I, as an interventional cardiologist, I bring my expertise in chronic and lifestyle diseases, and thereby our team bridging clinical medicine, genomics, and AI innovation. The technology, what we are using is Veletix AI engine, which unifies genomic, medical, and lifestyle data. Conversational AI assistant to explore your DNA interactively. Future-ready bioinformatics pipeline, scalable, accurate, and reanalyzable. Most important aspect of using AI technology is that our data should be reanalyzable, because it should not be that we use it once and it's gone. And comprehensive best-in-class reports. So this is a typical Gene Sutra report wherein we give disease predisposition by polygenic risk scores, pharmacogenomics, which is the data about drug response insights, nutrigenomics is personalized diet and lifestyle that we offer you, and rare variant and carrier status analysis, that is single genes running in families. Not only lifestyle disease, we explore the entire depth of genetics, and we can also offer you what genes you have not asked for. If they are found abnormal, we can give you that in the report, and actionable recommendations for patients and clinicians. How we are different is individuals own their genomic data with lifelong access with us. AI first insights, not just static reports, clinician driven innovation for real world adoption, and scalable global model built in India for the world. The future that we want to build with our brand is personalized health twin, AI driven preventive care, global genomic intelligence network, and seamless integration with healthcare. Thank you.
Thank you so much, sir. Thank you so much for this talk. It really illuminated how artificial intelligence is reshaping the way we understand and interpret the genomic data in medicine. The clarity with you explained the complex concepts and practical perspectives are truly enriching. Thank you so much. We have a few audience questions coming in.
Please.
The first one is, in what ways can AI enhance the interpretation of complex genomic data to support the precision medicine and clinical practice, which you already covered, but if you could summarize.
So I can give you my own example. I was the first patient for my own brand, and I am obese, and I have a strong family history of coronary artery disease and hypertension. So when my data came in, the polygenic risk score definitely said that vis-a-vis Indians, I have 70% more chance of being obese. And not only that, my nutrigenomics report pointed out that I have genes which actually go for inability to lose weight, and I have very poor satiety response. And also I am gluten intolerant, I am lactose intolerant, and I have certain food allergies. And mono unsaturated fatty acid is good for me, but too far, that is what we use as a fad, polyunsaturated, is not going to work for me on my genetic basis. As far as my coronary artery disease score was concerned, I had a negative polygenic risk score. So what it meant that I may get it in future as an epigenetic part or as a lifestyle disorder, I don't know. But on genetic basis, it was negative. So I'm less worried about that. Had it been positive, I would have started a blood thinner immediately. So this is how a gene sutra or a genome testing report helps shape you with your overall management as an individual. Also, on my pharmacogenomics report, there was a drug which won't act in me, that was called voriconazole. So we give in our report or in our brand, we have almost 75 drugs which we analyze. Voriconazole is one of the antifungal treatment which is used as a life-saving drug as a last resort in ICU infections. So probably this report should be with my wife, and maybe I don't know if it's required and I'm suffering, she can tell the doctors, don't use this drug, it won't work anymore. So this is a brief example to understand precision medicine on an individual basis.
Okay. And there is no AI talk without the talk of ethics and data privacy. So what is your stand on that?
So as a company or as a brand, we have strong SOPs to manage that. Our data remains with us. And we take informed consents of majority of patients whom we consult directly. And our protocols are, we offer free genetic counseling, either pre or post. And during that also, we can take informed consent of our patients.
Got it, sir. One thing that I was thinking was that we have moved beyond genomics now. We are talking about proteomics and metabolomics and stuff like that. So what role do you see AI playing in integrating these multi-omics data?
Ma'am, you're very right, but multi-omics, the holy grail or mother of all omics is genetics. Because when an embryo is getting shaped. First is the X and the Y, or the X and the X chromosome have to meet. And that's how all other things get into shape. So genetics is the basis or mother of all other omics.
So first we have to conquer that,
Yes,
and
ma'am.
then maybe okay. Got it. Got it. Thank you so much, sir. Let me just see if there are any final audience questions. Yeah, one was the challenge. Like, what are the challenges that exist in applying AI to genomic research while ensuring the data privacy?
Yes, ma'am. So I think we need definitely we need international cooperation on that aspect. Definitely we have to integrate, and that's the way to move ahead. But I'm sure that as AI world is progressing, we will do it very fast.
Okay. Okay. Thank you so much. Thank you, Dr. Kamaldeep sir and Dr.
Thank you, ma'am.
Kaushik sir, to giving us your time and like being available to take this talk at Doctors Med AI Web Hour. So at Doctors AI for Med AI Web Hour, we do this every month. We meet second Thursday of every month, and we talk about like all the medicine and AI, the integration of medicine and AI. And we have two guest speakers who talk about their expertise. We discuss anything and everything regarding that. We will be having our next Med AI Web Hour on the second Thursday of October, which will be 9th of October. Which will be followed by the Doctors AI Global Summit. So Doctors AI Global Summit will be happening on 15th and 16th of November 2025 in Bangalore. Please do join the Doctors AI groups. We will be sharing a QR code for joining the WhatsApp group of Doctors AI, and you will get all the information about the summit, which will be taking place on 15th and 16th of November in Bangalore. So we all expect you to conference and like make the most of it, because this is the very new thing that we are doing in India, the Doctors AI community, of bringing about all the faculties, the speakers from India and international faculties as well. So do scan this QR code, do join the WhatsApp community, where we will be sharing all the information about the Doctors AI Global Summit that will be happening in Bangalore. This is the first time that we are having the Global Summit offline. Last year it was an online. It was on an online platform. So please do join us, and thank you everyone.